Hey everyone, today I'll be reviewing the 2010 AMC problems 6 through 10. Starting with problem 6. Which of the following figures has the greatest number of lines of symmetry? A. Equilateral triangle. B. Non-square rhombus. C. Non-square rectangle. D. Isosceles trapezoid. Or E. Square. We can start off by drawing all the shapes that the problem gives us as options. Okay, starting off with the equilateral triangle, it has 3 lines of symmetry going down its altitudes, or heights. The rhombus has 2 going down its diagonals. The rectangle has 2 going down its heights. The isosceles trapezoid has 1 going down its height. And then the square has 2 going down its heights, and 2 more going down its diagonals. Therefore, E, the square has the greatest number of lines of symmetry. Okay, problem 7. Using only pennies, nickels, dimes, and quarters, what is the smallest amount of coins Freddie would need so he could pay any amount of money less than $1? Well, the largest amount you can have that's smaller than $1 would be 99 cents. So, we can set ourselves up a table with 99 cents at the top center. We can start out by using 3 quarters to minimize the amount of coins, which leaves us with 24 cents. Then we can use 2 dimes, which is 20 cents, which leaves us with 4 cents. Lastly, we can use 4 pennies, 4 cents, which leaves us with 0 cents left. Adding up the number of coins, we get 9. But if you notice, we don't have a 9 option. So, we can assume that the problem wants us to use one of each coin, which we didn't use nickels in this case. So, what we can do is set up another case with our table and 99 cents back at the top. Going through the same process, we're going to use 3 quarters, 75 cents, which leaves us with 24 cents. This time, we can use 1 dime, which is 10 cents, which brings us down to 14 cents. Then, we can use 2 nickels, which is 10 cents, which brings us back down to 4 cents. And then, from there, we can use 4 pennies, 4 cents, which brings us back down to 0. Then, adding up the number of coins, we see that the answer is B, 10 coins. Okay, problem 8. As Emily is riding her bicycle on a long straight road, she spots Emerson skating in the same direction, 1/2 mile in front of her. After she passes him, she can still see him in her rear view mirror until he is 1/2 mile behind her. Emily rides at a constant rate of 12 miles per hour, and Emerson skates at a constant rate of 8 miles per hour. For how many minutes can Emily see Emerson? First of all, we notice that they are skating in the same direction, which simplifies the problem. Then we see that Emily is behind Emerson for 1/2 mile, and then she is ahead of him 1/2 mile. This means that Emily can see Emerson for 1 mile. Then we see that Emily rides 12 miles per hour, which is 4 miles per hour faster than Emerson's 8 miles per hour. We can imagine that Emerson is stationary as Emily moves past because Emily is 4 miles faster. Therefore, Emily can see Emerson for 4 miles per 60 minutes, or D, 15 minutes. Okay, problem 9. Ryan got 80% of the problems correct on a 25-problem test, 90% on a 40-problem test, and 70% on a 10-problem test. What percent of all problems did Ryan answer correctly? First of all, we can find how many problems he got correct on all 3 tests. He got 80% of 25, which is 20. He got 90% of 40, which is 36. And then he got 70% of 10, which equals 7. Adding these 3 numbers up, he got a total of 63 problems correct. The total he had was 25 plus 40 plus 10, which gives us 75. Now, looking at the fraction 63 over 75, we can't easily see how much percent that is. So, what you can do is divide both the top and the bottom by 3, which equals 21 over 25. Then we can multiply the top and the bottom by 4, which gives us 84 over 100. So the answer is D, 84. Okay, last problem for this video. Problem 10. 6 pepperoni circles will exactly fit across the diameter of a 12-inch pizza when placed. If a total of 24 circles of pepperoni are placed on this pizza without overlap, what fraction of the pizza is covered by pepperoni? So we can draw ourselves a little diagram. Let's say this is our pizza and it has a diameter of 12 inches. And then the problem tells us that 6 circles of pepperoni fit across the diameter. This means that each diameter of the pepperoni is 2 inches. So now all we have to do is find the area of one pepperoni circle, multiply by 24, and then place it over the area of the entire pizza. So the area of each pepperoni would be pi times the radius, which is 1, squared, which gives us pi. Multiplying this by 24, we get that 24 pepperoni slices is equal to 24 pi. Then, finding the area of the pizza, it will be pi times the radius, which is 6, squared. This gives us 36 pi. Finally, we can write the fraction 24 pi over 36 pi, which is the area of the pepperonis over the area of the pizza, which gives us 2/3. Therefore, the answer is B, 2/3.